Welcome to Lesson 8, example number 5, and it gives us that the column of example 4 is to be supported on a drilled and belled caisson. The allowable soil bearing pressure is 4,000 or 4 KSF or 4,000 PSF. What should the bell diameter be? And this, instead of a situation where you have I know in the last example I drew it. Anyways, I drew it like this, where 1, 2, 3, 4, with 4 piles coming down. In reality, I'm betting that they intended it to look like this, and this is from a plan view, where you have 1, 2, 3, 4, and then you have a giant column coming down in here. I'm betting that's what the intent was. It's more of a corner of a building that they decided to use drilled piles. So looking at that from an elevation view, you would have your footing, and you have your 2 piles going in. So this would, be 2 piles deep, and you would have your column or your wall or whatever coming into here. I'm betting that's what they meant for it to look like. Anyways, on this example, you have a circular, so it's going to look like this. Let's make it look like that. Here's your P load, which we know from last example was 200 kips. And then at the bottom, it's going to bell out like so. Obviously, this is not the most perfect drawing in the world. That does not look good either. It's not the most easy thing to do, this, to draw on this tablet. Alright, so there we go. And, of course, we want to know, what is that diameter to make this work? And if it bells out at the bottom, it's going to give you more bearing area, so that's going to help you out. All right, I think that should be good. And we know we have a allowable equals 4 KSF. All right, so this is a pretty straightforward problem. We know that your bearing pressure, which we can call FA for simplicity. A lot of people will not call it that. So your stress or your pressure, and that might be a little misleading, call it FA, but let's not do that actually. Let's just call it bearing pressure. SURE. So bearing pressure equals P over A, which is your P. This is your P load, kind of your axial load coming down, and A is going to be the area. Let me change colors. This area right here. All right, so we know what our our allowable bearing pressure is. Put allowable here, and that's going to be 4 KSF. And then we have P is 200K, so we solve for A. Obviously A is going to be the area of that circle. But let's figure out what our A, now it doesn't have to be min or max, and if you think about it, you can say, well, I know it's going to be our minimum A. Because if our A is higher, then our our actual is going to be lower than the allowable, which is what we want. So let's solve for A min, and A min equals 200 divided by 4, which is 50 foot squared. All right. Now we need to say, well, what is the area of this circle right here, the bearing area? And bearing area is area of a circle equals 2. That's not 2 pi r. Sorry, that's circumference. Pi r squared, and that also equals pi d squared over 4. pi d squared over 4. And typically when you're, this is what I remember when I went through geometry, I memorized this. But this is actually a more useful formula in engineering because you'll more use the diameter. You don't often go in and say, oh, this is my radius. So anyways, I'd memorize this if you can. If not, you can derive that from this. And if you're not sure, you can just put something in for r and make sure that they equal each other. So that's what I used to have to do when I just was starting, because I always forgot this equation right here. Anyways, I'm talking too much. Let's just do this. So we're solving for d. Actually, so pi d squared over 4 equals 50 foot squared. So do a little math, solve for d. 50 times 4 divided by pi, and you get d squared equals 63.66 foot squared, and then you take the square root of that, so the square root to the 0.5 is 7.98. D equals 7.98 foot, because the square root of the units squared equals just plain old feet. And then you're going to want to round up to 8 foot. And that's minimum. Sometimes you can say, well, depending on what factor safeties you have, what issues you go, we're assuming this allowable bearing pressure already includes all of factor safety. So this is actually your allowable, when you get to allowable, saying that's what you can get, not your unfactored. This is more, as I would look at, it's factored. So it's got all safety factor in there, is what I'm trying to say. So your answer is 8 foot diameter. D. Diameter equals 8 foot. And was that what they were asking for? What should the bell diameter be? Yes, and our answer is 8 foot. Let's go ahead and check that. And with the study guide answer, and they did the exact same thing. They say use 8 foot. They say 8 foot equals 0 inch, but it's 8 foot 0 inch, I think is what they meant to say. They meant to say 8 foot 0 inch bell diameter. Alright, I will see you on the next video.